Good afternoon, everyone. Hope I'm not interrupting too many people's lunches. We could always relocate this to the restaurant if people would prefer. So as just been introduced, I've worked in the industry for quite a while now, and I spend a lot of my time talking with customers of all shapes and sizes around how they're going to transform their environments, not just network transformation, but cloud transformation, largely focused on how organizations are going to deliver agility and better working experience for their users as well. So I'm going to touch on some of those key points as I move through the slides here today. There should be time at the end for some questions, but also I'm around. We have a stand downstairs, so by all means pop down and come and say hello if you want to have a deeper conversation. Specifically today, I'm going to focus on how we as a vendor, Palo Alto Networks, leverage cloud hyperscalers and machine learning to enable organizations to head towards achieving zero trust. And when we talk about zero trust, there are three key principles that you need to be following. Hopefully I'm not teaching anyone here to suck eggs when I talk through these three, but these are what we align to from a product strategy perspective and what we're trying to help organizations achieve as they move down a journey of zero trust and transformation. The first is around least privilege. You need to ensure that users can only get access to the specific applications or the specific sets of data that user should get access to. You need to remove explicit trust from an organization. It's no longer acceptable to just assume because a user works for your company, has a corporate laptop, that they can get access to everything. Especially with remote workforces, there's a lot of organizations that are taking a hybrid approach as we go forwards. And this becomes really quite hard to achieve. If you haven't got there yet, it's time to start that journey. And you also need to make sure you're securing every digital transaction. So you can't just say, we've authenticated that user, we know who they are, we're just going to allow them access. You need to make sure you're inspecting that traffic, looking for lateral movement and threats passing through the organization to ensure you're protecting the data and the organization. Now, there's a lot of vendors out there that have tried to approach this using what we call ZTNA 1.0 approach. And they've taken a proxy broker type architectural approach to this. And it fundamentally goes against the principles of zero trust. They violate the principle of least privilege by only authenticating a user once, and they don't validate the real application. A lot of other vendors out there go about validating application by saying it's TCP 443 and therefore it's Office 365. That just doesn't work in a security world. A lot of the approaches we see in the market take an allow and ignore approach. So once they've validated who the user is and they've said, we think that's Office 365 because it's going to the internet on a secure port, they let the traffic through and don't provide any inspection at all on that traffic. They also have limitations around their ability to inspect the traffic. So they can't do things like decryption a lot of the time. They can't look for threats within the traffic. And they can't protect against all types of data passing through that traffic or protect all applications. What good is a solution if you've still got to continue to use maybe a legacy VPN to provide remote access into certain applications or for your SOC to get remote access onto machines for diagnosing issues? So for us, we approach this from a different perspective. We announced ZTNA, sorry, I'm turning American working for an American company in my pronunciation of letters. But we announced ZTNA 2.0 earlier this year, and it's a fundamentally different approach to how you go about delivering zero trust within an organization when you have a workforce working in a hybrid environment, perhaps on holiday, perhaps sat in an office. And we align to the 5 key principles. So we enable organizations to achieve least privilege access. And I'll walk through how we do this actually in a second. We provide that continuous trust verification. So we're always ensuring that user is who that user says they are. The application is the real application and doesn't change its behavior. And the device itself continues to maintain compliancy with a corporate standard. We have the ability to provide continuous security inspection across all traffic flows. We also are able to protect all data, so we can inspect that data to see if it contains things like credit card numbers, passport numbers, driving licenses, people's personal details, and we can take preventative action if we see it. And really importantly, we can secure all applications. We're not limited to just web-based protocols. We can secure things like SMB going into a data center, and we can also support server-to-client flows, which is a really important use case for a lot of organizations still. And the clicker is not clicking. So we do this by deploying an agent onto the endpoint that provides our connectivity into a cloud-hosted security service. And I'll talk a bit more about our cloud-hosted service as we move through this and how we deliver that. But our agent allows us to identify who that user is using MFA if it's required by the organization, and also the ability to continuously validate who that user is. We can inspect the posture of that endpoint, and we can use that in policy to control what that user and device can get access to. And we also validate the application at a layer 7. So we inspect the packet headers and the payload of the application to ensure that when that user's gone to a website, it really is Office 365, or it really is SMB or SSH. And we can ensure that that application is what they expected it to be. We overlay continuous trust verification on top of that using a combination of technologies we've developed over many, many years now. That allows us to revalidate that endpoint posture continuously. So imagine a scenario where a user's on a personal device, a BYOD device, and they're connecting to corporate resources. The user has admin rights on that BYOD device, and they could go and disable things like the local firewall or the endpoint protection. You now have a device that's a risk to the organization. We can detect that automatically, and we can dynamically change the policy that's being applied to that user's traffic based on the posture of that device. You may want to allow them access to the service desk or to the internet only, and block access to corporate applications, and we can deliver that capability using that. We also continuously look for behavioural changes in the application traffic, and we're able to detect when that's no longer Office 365 or Slack or Box. Perhaps the application itself has been compromised, and we can therefore provide preventative action in the case that the application is compromised and prevent against things like data leakage. Leveraging our cloud-delivered security services, we're able to provide full inspection and protection against both known and unknown threats. This includes things like DNS-based attack methods, DNS tunneling, domain generation algorithms, as well as a whole host of other DNS-based threats that the attackers are using today. We can provide security inspection on web traffic, and we use machine learning as well to ensure that we're doing this in real time, and I'll talk you through some examples of how we help protect against real-time based attacks on the web. We overlay this with our next-gen CASB and DLP capabilities, which therefore allows us to inspect files leaving the organisation or coming into the organisation and match them against a set of policy that you can define. We have built-in policy that's there, but you can obviously tweak it to your own needs. And that allows us to say users that are in the finance department can upload credit card numbers to specific applications because they need to be able to do that for their job, but we're going to block other users in the organisation for doing so. It might control what the marketing team can upload to OneDrive, for instance. Perhaps your organisation uses Google G Suite, as we as Palo Alto Networks do, and therefore we want all of our users to use Google G Drive. But your marketing team may need to share files with another organisation that uses OneDrive, and we can provide that fine-grained control over which group of users or even individual users can access applications and what direction they can go. So maybe you only want to allow them to upload but not download anything. And then what types of files as well. So maybe it's only publisher documents if it's a marketing team and they're going to their publishers, but you don't want them to be able to upload Excel files, for instance. We can give you that fine-grained control. And most importantly, we can secure all applications. Doesn't matter whether that's a web-based app going to the internet, whether that's something like SSH, SMB, going back into a traditional data center or a public cloud location. And we can also support those flows that originate out of a data center or out of an application back to the end user's device. Things like device provisioning or group policy that some organizations still use, we can support that through our service. If I take a step back, ZTNA 2 for us fits into SASE. SASE is a trend that was announced a few years ago by Gartner, and it's ultimately a combination of technologies that come together as a cloud-delivered service. So from Gartner's vision point of view, it's the consolidation of networking and security in a cloud-delivered service, and we have the full set of capabilities within our SASE offering to deliver those capabilities to yourselves. So I've talked a little bit about ZTNA there, but we can also provide next-gen CASB functionality to secure SaaS applications, both via an inline capability as well as via an API capability. So if you have corporate use of Office 365, we can connect to that via API, and we can provide controls over whether your users should be able to share files externally, for instance, whether they've got malware sat in their Office 365 email inboxes, and we can take preventative action against that. We have secure web gateway capabilities built into the service as well, and that includes things like proxy for migration purposes. For those of you that know Palo Alto networks, we've been big advocates of getting rid of proxy in every organization because it's not a way of actually securing traffic. We provide it as a connectivity mechanism for migration purposes, whilst we take a customer on a journey to getting them to a far better way of connecting and securing their traffic. We have SD-WAN capability that's built into the service, a cloud-delivered SD-WAN service that automatically establishes via zero-touch provisioning into our Sassy Fabric, and essentially makes your branch part of our Sassy Fabric, and that allows things like transitioning away from MPLS really easy. And we overlay that with our digital experience management capabilities. One of the key conversations I have with a lot of customers, especially outside of the security teams of that customer, is what is this going to go do to my user's experience? When you move from an on-premise service out to the cloud, there's a lot of concern around performance, user experience, productivity of those users, and our capabilities we have here. And I'll walk you through actually a bit of a walkthrough of what this looks like and what capability it provides. But it gives the organization the ability to rapidly understand a performance issue and where that's affecting users' experience, and therefore be able to remediate it quickly. Ultimately, our SASE solution enables users and devices wherever they're located. That could be sat in your office, that could be working from home, it could be the coffee shop, on a plane, or on the beach, to data wherever that resides. The internet, SaaS applications, public cloud, or corporate data centers that organizations are still running. And we provide the same security capabilities across all of those flows. So to enable us to do this, there are three key things, really. It's deep security expertise, which Palo Alto Networks, we're a leader in the cybersecurity space. We've built up very deep expertise in this space over many, many years now. And I'll talk about what we see going on in the world and how many threats we protect today. You have to leverage the cloud hyperscalers to deliver this. We are not an organization that runs data centers or networks. We don't have expertise in that space. So we didn't want to get into that space when we launched our SASE and ZTNA offering. We took a conscious decision to leverage the people that are best in the game at that with the cloud hyperscalers. And you also need to use machine learning to deliver real-time protection against threats. It's no longer acceptable to see a threat, spend time analysing what it's done, and then go and remove it from endpoints or clean up from the breach. You have to protect against those threats in real time to stop them in your organisation. So from a deep security expertise point of view, we are seeing and blocking 224 billion threats a day as an organisation across our platform. This drives our threat intelligence service, which is a shared service across all of our customers and all of our products. So we might see an attack, a zero-day, hit a bank in China, as an example. We would analyse that threat and we would push in updates to all of our customers across the globe. And we're pushing out 4.3 million unique updates to protect against different attack vectors on a daily basis. We've also done a lot of work recently with some of the chip manufacturers to enable us to leverage machine learning within the cloud hyperscalers. And this is allowing us to detect and protect against threats in real time at a rate that's 180 times faster than the nearest competitor. So our decision to use cloud hyperscalers was driven by not wanting to get into the data center game. As I said, we're not experts in data centers. We don't want to be. So we decided to use the cloud hyperscalers to help us deliver our service. 3 key reasons for that. Scalability is one of them. There's no one that can scale as well as the likes of GCP and AWS can. Performance is another one. There's no one that can dispute that GCP had the fastest tier 1 network backbone in the world. And resiliency as well. For us to have built out the data center environment to provide the level of resiliency that we get out of the service that we deliver would have taken years to achieve. So we use today a combination of GCP and AWS to deliver our service. This gives us 62 compute regions across the globe in a highly resilient architecture with 193 disparate data centers. This enables us to protect against not only a local region outage, but also an entire cloud provider outage within a country. So if we lose GCP in the UK, we have AWS in the UK as a backup as well. And I'll touch a bit more on that as we move forwards. We also leverage the cloud providers' points of presence in ISPs to provide reduction in the latency from that user's connectivity into the service. So when a user connects into the Prisma Access backbone, that goes across their last mile ISP into the core of that ISP and then hops on to the GCP backbone and our service where GCP and AWS peer with that ISP. So we reduce last mile latency, and as a result, we also reduce middle mile latency by leveraging the GCP and AWS backbones for transit across the globe. A couple of examples of this. There is a Premier League football club that owns stadiums in Manchester, Australia, New York, and a few other locations. I've probably just given away the game, who it was. They were using traditional VPN across the internet for transferring files from Australia back to their data centers in Manchester. This was taking around 20 minutes for a gigabyte size file. Through our service, we reduced that to 3 minutes for that transfer. That's how performant the backbone is that we have access to via GCP and AWS. We also provide SLAs around this because of our usage of GCP and AWS. We obviously have uptime SLAs, as you'd expect us to have, 5 nines. We have an SLA around security processing, which is the best in the industry, of 10 milliseconds for security processing, including SSL decryption. And we're the only vendor in the space that provides an SLA around access to SaaS applications. So Office 365, Google G Suite, Salesforce, Box, Slack, and a couple of others, we have the ability to provide SLAs around because we leverage the cloud providers peering with those SaaS applications to provide direct access from cloud to cloud. So data plane isolation is a big thing for us. We provide dedicated security processing nodes for every single customer. So when you onboard to the service, it's a unique environment for yourselves that's not shared with any other customer. This is really important because if you imagine a scenario, we're rapidly approaching Christmas, the retail space is going to get very, very busy. If you've got retail customers sharing a data plane processing environment with yourselves, at Christmas, they are going to cause performance issues for you. So by providing dedicated data plane processing, we don't suffer from that issue. We also don't share back-end data as well, so your logs aren't getting merged with other customers' logs. And we provide dedicated public IPs as well for things like whitelisting into SaaS applications. We don't share IPs across customers. As part of the GCP and AWS capabilities we have, we can provide both interzone and intercloud failover, and we've just seen the benefits of this. So in a scenario where there might be a complete cloud outage in a region, we automatically fail that traffic across to use the other cloud provider. A good example of this was the recent outage that was caused by a fibre break in the south of France that caused other vendors and some of the big ISPs to have to manually reroute traffic across different parts of the world. That caused big latency issues for a lot of customers and actually downtime for quite a lot of customers. Our service automatically detected that, leveraging the GCP and AWS backbones that we use, reconverged automatically to route around the issue, and we continue providing service for our customers without any downtime at all or any impact on performance. So let's talk a little bit about machine learning and how we leverage that to deliver real-time protection. So imagine a scenario where your user, an exec user, gets an email. What's the first thing they go and do on this email that's hit their inbox? Anybody?
Click the link.
Correct. Correct. They don't do what we've taught them to do, which is go and have a look. Is it a genuine email? Is it from someone you trust? Should you be clicking on a link? No, they click on a link in it. And that takes them off to a website with another link on it. And they obviously go and click on that link and they get hit with a drive-by download, or maybe that malicious website steals their credentials. Credential theft is one of the biggest threats we're seeing out there at the moment. Big problem for a lot of organisations. We know email security doesn't do a good enough job of protecting against phishing. So you need to be able to protect against that web request in line and in real time. By leveraging our machine learning capabilities, we're able to analyse the website, the content, as well as things like when was that site registered, what links off from that site to other sites does it have, do we see other users, other customers going to it from across the world, and we make a decision in real time and we can prevent access to that website, therefore removing the risk of your users getting hit by a phishing email. Now, before I walk through another couple of examples of various capabilities we have, our SASE platform allows organisations to consolidate multiple security tools down into a single platform that can be leveraged from a single management portal to secure against all different types of threats. Most of the time when we're talking to organisations, consolidation is a big thing for them. We see them running multiple tools. We've got organisations where we've taken them from 180 security tools down to a single platform approach to it. This helps with the day-to-day operational complexity as well as ongoing costs of the service. So let's have a little bit of a look at the end-to-end visibility piece here. This is really, really key for a lot of organisations. One of the things we see with users when they're having user experience problems is they try and find ways of working around that experience problem, disabling their connection to your corporate service, breaking out directly on their home internet, or maybe going and using a personal device, or even worse, closing the laptop lid, going and making a cup of coffee and just giving up for the day. So being able to understand where performance issues are causing user experience issues is key. And even more critical is giving tools to people in the service desk, the network teams, so they can rapidly resolve those issues for your users. We provide high-level visibility across the globe, which shows you where you have issues. So you can see here an issue over in US East. And we give you the ability to drill down into that information. So we can see specifically, for instance, there's an issue with Slack right now. The experience score is very, very low. And we can see we've got a user as well that's got a very poor experience score. And we can drill into that. So we can take an overall look at all users within the organisation, all applications or all sites. And we can see which users or groups of users are being affected and pivot down into specific examples and really understand the detail there. So if we pivot into Anchor, one of our users, we can see that he's having a bad experience with several applications, in fact, but Slack is the key one here. That's stopping him actually being able to work. And we give you visibility over time of things like Wi-Fi connection and where the experience score has dropped or peaked. So we can see he's obviously moved from home into the corporate office. His experience has gone down. Maybe there's an issue with the corporate Wi-Fi that we need to go and look at. He's then moved to a Starbucks coffee shop and still has not great user experience. And we show you trending against the rest of the organisation as well, so you can help understand whether that's an organisational wide impact or whether it's just a single user or small group of users. We also provide full end-to-end path visibility across the underlay from that user to the application. So you can see where latency, jitter, packet loss on the underlay is causing a performance issue. This has actually just helped us solve a problem for a customer. We were running a POC over the summer with a customer that has offices across the UK. They have an office in Manchester. They actually weren't testing in Manchester, but it came up during our conversations that their office in Manchester was having issues talking to Office 365 based out of the Azure DCs in London. So we put an appliance in to their Manchester office, an SD-WAN appliance, connected it into our SASE service. And within a day, we were able to see the hops through the underlay. And the ISP was routing this traffic via Island to come back in to Azure UK. And that was causing additional latency on the connection and causing an impact on users' ability to use Office 365. We've also literally just 2 days ago, announced API-based integration with Zoom. This gives us the ability to help you understand where there's a Zoom performance issue within the Zoom environment. We integrate with the Zoom QSS service for this. And from the dashboards, we give you visibility around where things like Wi-Fi performance is affecting Zoom calls, or where a user's device is too old and needs to be updated to solve problems with Zoom. So we give you fine-grained visibility around things like how much time is being spent on screen sharing, video, voice calls within Zoom, how it's performing overall, as well as that individual visibility for per user or groups of users. So moving into sensitive data, and I'll touch a bit here on how some of the capabilities we have to provide DLP services via our SASE and ZTNA solution. So we have a user that works in finance. They have a Word document with various credit card numbers in it. Exactly the sort of document that is sensitive, shouldn't be getting uploaded, shouldn't be getting shared with other people perhaps in the organisation, and would cause you regulatory compliance issues if it was to be shared. So in an example here, we have Alex that's working in a collaborative manner on a Slack channel with some of his colleagues, and he's accidentally posted that document onto this Slack channel. That's a big problem for our organisation. We're sharing people's credit card numbers with people that shouldn't have access to them within the organisation. That will immediately generate an alert to the admin, and the admin will get an alert in Slack or your other collaboration tool of choice. We use Slack, as you can probably tell. Your admin from here can click on that link. This could be a SOC analyst, it could be your security admin, it could be your data protection officer, for instance, and that will take them off to our management console, specifically with the details of this incident open. We give visibility around what the incident looks like to the SOC analyst, who the user was, when it occurred, the type of file. We provide visibility into why that's an issue, and we can masquerade out the credit card numbers, which is normally a requirement for most organisations. From here, your SOC analyst or your security admin can take preventative action. They can quarantine the user, they can go and remove the file, they can send messages off to the user as well. Now, if I take a step back here, we also provide dashboard-based visibility of all DLP breaches within the organisation, including who the user is, what policy that's hit, and what actions were taken. Now, that's great that we're empowering the SOC analysts to take action, but what we actually really want to be able to do is stop that in real time. If we've defined a policy that says we don't want users to be able to share files with PII, or PCI data in this case, or we do but only in certain circumstances, then we give you the ability to do that, and we can take things like auto-quarantining the file from the service and generating alerts, so we can move that to a real-time preventative stance. We also have the ability to empower the end user themselves. So we can provide the end user with an alert that tells them they've caused a data leakage issue. We can tell them why, and that user can go and click on the button themselves to take self-healing actions. And with that, I'll open up to any questions. I don't know how I'm doing for time.
You're perfect on time.
Good, good, good.
Yeah, any questions from anybody? I'm just interested. So in terms of ZTNA 2.0, are there any kind of industries in particular that you're seeing more kind of they're more open to that?
We're seeing traction across every vertical right now. Some have, the move to remote working was driven by COVID. We'd seen it prior to COVID. There was a lot of organisations that were already moving to a hybrid type approach, but COVID sped that up considerably for every organisation. We're in a place where we see lots of organisations that still don't know what they want to do going forwards. They don't know whether they want to stay hybrid. They don't know whether they want to go back into the office space. There are certainly some organisations that are taking the decision to bring everyone back into the office, and there are some that have taken that decision to continue remote working. So for us, we're seeing every organisation across the board wanting to look at how they move to a cloud-delivered service and away from that traditional approach, which is putting VPN concentrators or security appliances into a data center and backhauling everybody to the DC, because it just doesn't solve for a lot of the traffic use cases in today's world.
How do you bootstrap a new device? Do you need like physical control over it, or do you use something with like hardware-based trust as an anchor?
So for the actual endpoint itself,
say you have a new remote worker that's somewhere far away with his laptop.
Yep.
How do we start getting him onto the corporate network?
how do you start? So normally we're deploying the agent onto that device, which would be managed by something like an MDM solution in most cases. So you're
assuming in a way that you can already trust the device to install something, and not that it's just not going to install it into a script, then talking to an application that pretends to be your endpoint.
Yeah, so once you deploy the agent onto the endpoint itself, we're able to validate things on the endpoint. So we can do things like check it's on the domain, we can check for certificates that exist on that endpoint, both machine and user certs. We can check registry keys, process and stuff like that.
That your endpoint is actually running, and not
Yes.
that there's another application that pretends to be your endpoint, so you're
Yes.
happily trusting all the output. Is there anything to prevent that sort of attack like that?
So if you ended up with somebody that had cloned a device into, for instance, a virtual machine, is that the question? Would you be able to detect?
No, it doesn't even need to be cloned, right? So you're sending your endpoint agent. Now that person isn't ever running it. They have their own, basically malware that pretends to be your endpoint. Could you tell that you're not talking to your own code, but to malicious code who pretends to be your endpoint?
We can look at specific indicators on the endpoint itself to detect that it is a real hardware machine, for a start.
You know, you trust whatever the endpoint
Well,
is sending to you.
That's a good question.
Fabricated data.
Yeah, that's a very good question. There is a risk, yes, that you could have an agent deployed onto a machine that's pretending to be a machine, and it's very, very hard to see that it's not. Just because the agent is on a machine doesn't mean they have connection to the service, though, which is the important thing here. We have to identify a user. That's normally with MFA as well. And then we're constantly inspecting that traffic as well. So even if you have a compromised endpoint in some way, shape or form, we're able to detect and prevent that spread, the lateral movement that could occur into the data center. So I'm not going to say we can't stop a compromised machine joining, but we have all of the capabilities to prevent that threat from spreading. Thank you.